Good morning, grade 3. A warm welcome to today's social studies lesson. This week, we're going to look at some very important map and graph skills. You're going to learn how to use a line graph, and you will also learn how to read and interpret a population map. So please do not forget to pause this video or replay it for better understanding. Great, so the learning objectives of today's lesson are 1. You're going to read and interpret a line graph, and the second objective is that you'll recognize that a population map shows patterns of settlement and population density. Do not worry about the vocabulary, we're going to go through it in just a short while. On this slide, we're going to see why do you need to use a line graph. So, the line graphs are used so that people can observe changes over a certain period of time. So remember that a line graph is a very important tool and a very easy one to read in order to see how numbers change over time. Now, there are 4 steps that you're going to follow when you try to read a line graph, and I'll represent that shortly. So let's go through the first step. You're going to obviously read the title so that you know what data this graph represents. Step number 2, you're going to read the labels that are on the bottom and the side of the graph, because those labels tell you what those numbers represent. Step 3, you're going to follow the dots on the graph, because they represent and show the number for both the side and the bottom label. And step 4, you're going to follow the line graph to see how the number changes over time. Let's see how you're going to do this. Please open up your practice book to page number 82, and here let's read the directions together. The charts below show the high temperature in 2 cities for 5 days in July. Plot the temperatures on the line graphs and connect the dots. Then answer the questions that follow. So, first of all, you need to establish what the direction said. Well, it said high temperatures in 2 cities for 5 days in July. I can see that because I can see city A, city B in the table and on this graph as well. And then they want us to do 3 things. Firstly, you're going to plot the temperatures on the line graphs. Well, that's easy. I have a table. I just need to pick up those temperatures and jot them down using dots. And then they want you to connect those dots. And why are you connecting those dots? Because as we've already discussed, that's what's going to show you the trend, how the change occurs. And then the third thing you're going to do is you're going to answer questions that follow. So let us begin by first plotting. Now, I've already done the plotting for you. You can see it right here. City A, city B. The title goes in, labels are very important, and once that is done, you need to check, all the dates are right here on the bottom of the graph, and both of these graphs, city 4, city A, and city B, and the temperatures are on the side in degree Fahrenheit. Perfect. Now, all what I need to do is go to the table, July 12th, 86 degree Fahrenheit. All right, where should I plot it? 75, 80, 85, 90. So I can see that the temperature is plotted in 5s. Keep counting. And they started plotting from 75 degree Fahrenheit. So I need to go to 86. Well, that's easy. I reach 85 and then just go a degree above 85 and plot that 86 right there. Draw a dot, like a fair enough dot, like something that's very obvious, very clear, and then so that it's easy for you to join those dots together. All right, then July 13th. So July 13th, 101 degree Fahrenheit, 101. Easy. I go to July 13th, I scroll all the way up, slide my finger down to 100, and then go a degree above for your 101 degree Fahrenheit, and you plot it like that. July 14th. Oh, oops, that's a very hot day. 104 degree Fahrenheit. Go to 105, slide your finger a little bit down, just a degree below 105, and then plot it right on July 14th. Right, and then do the rest as well. 95 is fairly easy. It's right there, I can see, and it's for July 15. And the same goes for July 16, right on dot 90 degree Fahrenheit. Perfect. And once you're done doing that, use a ruler. Don't do it free-handed, please. Use a ruler, connect these dots, and you'll see a trend. Now, it might go up, which means the temperature is rising. It's getting hotter. And if it goes down, that means that the temperature is dropping. It's getting a bit less hot. So we're going to look at these trends now. Either it is going to go down or it's going to go up, and then there is a trend the way it goes. If it goes very steep up, that means a sharp up, multiple boxes are jumped, and it's a very sharp straight line, right? That means it's the temperature has changed abruptly, like super quick. But if it goes a bit slanting, that means it took a little while before the temperature dropped or hiked. We're going to see the example of this shortly. Now, once all these temperatures are plotted for both of the cities, it's time to answer questions. The first question is, on which day did City A record the highest temperature? So, key one, I go to City A. Great. I need to be careful what graph I read. So, City A, and I'm looking for the highest temperature that was recorded for City A. What day was it? So, I can either look at my graph, right? And the highest point on the graph, the highest little dot, is going to be the highest temperature. Remember, the temperature is going higher as we go up. So I can see that right there, that's the highest temperature recorded, and that's a 104, a little down below 105. Confirm it with your table just to be sure. And that's July 14th out there, right? So you write the answer. Simple. Question number 2. Which city had the lowest temperature on July 15? Great, this is going to be easy as well. The first thing I need to do is I need to establish, or which city are they talking about? They're talking about both the cities, right? And then they want me to compare because they're asking which city had the lowest temperature on July 15th. So July 15th, I'm going to look at the data for both of these cities. July 15, perfect. And I see that for City A, the temperature was 95 degree Fahrenheit, and for City B, let me go, and I see that it's a little down below 90, 89, and confirm my doubts from the table. I can do that. You can do that too. July 15th, perfect. So this sounds like City B, because obviously 89 degree Fahrenheit is lower than your 95 degree Fahrenheit. So the answer is City B. Question number 3. On which day did City A and City B record the same temperatures? Okay, so they want me to look at the data for both the cities, and they want to look at the day when both the cities experienced the same temperature. Okay, so I need to look at both the graphs. Great, I think what I could do here is that I could look into my table, because it'll be easier for me to figure that out. Numbers clear away. So let's look. All right, 90 degree Fahrenheit here and 90 degree Fahrenheit. Perfect. No other temperatures match on the other days that were recorded. So the answer is July 16th. Easy, right? This was the temperature, and you can confirm it on your graph as well. Right? You've plotted a 90 degree Fahrenheit for July 16th for both of these cities. Great. 4. Which city had the steepest drop in temperature from one day to the next? Or which 2 days did the drop occur? Great, so these are 2 questions, and what they're asking me, let's go back, reread, comprehend. They're looking for steepest drop in temperature. So you need to know what steep means, and we've spoken about it, but I'll show you what it means. So steepest drop in temperature from one day, this is what they're looking, and they're looking for the city that had the steepest drop. And then they're asking, what 2 days did this drop occur? So I'm going to look at my graph, and I'll stare at both of these line graphs. I'm looking for a steep line that goes down. Now, steep drop is like multiple boxes jumped and a sharp downward trend, right? Like a steep edge, rocky edge of a mountain, something like that. So what I see here is that this is your steep drop, by the way. This is me trying to explain the steep drop I'm looking for, not a steady drop, like a steep drop. Lots of boxes jumped in a sharp trend. So what I see here is this is where I see a steep drop. I see 2 boxes all the way from 104 to 95 degree, Even though there are other examples where there are drops, but not a steepy drop. For instance, from 95, or for city A, from 95 to 90 degree Fahrenheit, but then that's just 5 degree Fahrenheit. But 104 to 95 is quite a drop, right? And this has happened right here from 14 till 15 to July. These are the two dice. So the answer is city A is where I see this change, where the temperature dropped abruptly from 14 to 15 July. Great. All right, grade 3, now that we're done with the line graph, let's look at the population map. Please make sure that you pause and read this piece of information. You need to understand it. You should know what these terms mean in order to solve the next page. So let's read together why it matters. As communities change, so do their populations. Populations maps can show you where most people live. Learn. People are not spread out evenly on Earth. Different areas have different population densities. Population density is the number of people living in an area of a certain size, such as 1 square mile. A square mile is a square of land that is 1 mile wide and 1 mile long. Places with higher population densities are more crowded. Cities usually have the highest population densities. So here on this page we learned about the population density and what was meant by a square mile. You're going to look at that on the next page. So let's begin solving page number 88 and 89. Please make sure that you've got your book open. Let's do this together. So this is the population map of Kentucky. Let's read the directions. Use the map to answer the questions on the next page. Perfect. So the answers are based on what you read on this population map. I want you to look at the map key. You can see that the key has 4 distinctive colors or patterns. The first one is a solid gray, which means this is a very populous area. Lots of people living here. That's more than 100 people per square mile. That means the population density is high in any area that you see gray, dark, solid gray color on this map. And then you've got the second box, which has lines on it, which basically means that it's a little lower than the dark gray, solid gray. That's 50 to 100 people living per square mile, right? And then you've got 25 to 50, which is off-whitish in this slide, and then a very light gray for areas that are not very populous, and the density is quite low. 25 people per square mile. Let's begin answering questions. Question number 1 is, what is the population density of Louisville? And the first thing I'll do is I'm going to locate Louisville on the map, right? So that's where Louisville is, and I can see that it is a dark gray, solid gray color here. That means that the population is more than 100 people per square mile. That's how I answer it. First, I spot the place, then I look at the color, then I confirm it with the map key that I've got, and then I decide how many people. So that means Louisville is quite a popular area, and there are lots of people living here. Great, let's go to the next question. Which pattern shows the highest population density? Which pattern? This is easy. I just look at my map key and I see that the solid dark gray, because it says more than 100 people per square mile. Question number 3, which city has a higher population density? And then they give me 2 cities, Russellville or Bowling Green, so I need to compare. Step 1, I locate them on my map. Bowling Green, Russellville right below it. Perfect. Then I look at the pattern that these 2 places show on the map, and I see that Bowling Green, if I compare it with my map key, it's got more than 100 people, so lots of people living down there. And Russellville, on the other hand, it's got 50 to 100 people per square mile, which is lower than Bowling Green. And my question again is asking me which cities got higher population density. That means more people live, and obviously the answer is bowling green because it's got this solid gray color, which tells me that it is more populous. Great, let's go to the next question. Question 4, what is the population density of Middlesbrough? Again, I'm going to locate Middlesbrough on the map and I see it right there. Then I look at that little black dot for clarity, and I see that this is where Middlesbrough is, and it's got these lines on it, the pattern, and that can be compared with my map key, which tells me that's 50 to 100 people per square mile. So the answer is 50 to 100 people per square mile for Middlesbrough. Perfect. Easy, right? Question 5. Which city has a lower population density, Jackson or Richmond? First things first, let's locate them on the map. Jackson's there and Richmond's right there. Then I compare these colors with the key that is being provided on the side, and I see that Richmond's got the solid gray color, dark one, and Jackson's got this light off-whitish, just like a light color. That's 25 to 50 as per my map key, so 25 to 50 people per square mile. But my question's asking me which city has a lower population density, so the answer is going to be Jackson because it's got 25 to 50, whereas Richmond's got more than 100 people per square mile. Alright, grade 3, this brings us to the end of the lesson. Please do not forget to complete a very easy quiz that's being posted in eQuiz. And do not forget to complete the work on page number 82, 88, and 89 in your social studies practice book. Best of luck, grade 3.